name is Jeremy Baum. I'm currently a senior in the Material Science and Engineering program. My current specialization is general material science, but I have a special interest in polymers.
I'm Xiang. I'm a sophomore in the Material Science and Engineering department. The reason why I joined is because last semester, two seniors I've met introduced me to material sciences, and at that time I was looking for a major, so I did my own research on material science and found out that it's an amazing major in which you can do so many different things and there are so many different options. And so far, I really, really like it.
My name is Robert Kornfeld. I'm a junior, and I'm energy materials.
And why did you choose materials engineering?
Honestly, I came in as chemical, and it was awful, so I switched. And materials is all the best parts about chemistry and physics and all the things I actually like.
I'm Madison Sage. I'm a freshman here at the University of Maryland, and I originally chose material science and engineering, but I'm no longer that major. I am now a civil major.
Hello, I'm Andrew McGurk. I'm a junior in the MSc department, and right now I'm just generic material science.
So what made you choose materials from the beginning?
A friend sort of roped me into it around senior year of high school and got me interested, and then I took PNES 181, the Dialogue with the Dean class, and I wrote my paper for that class entirely on green applications of graphene. So that kind of said I was going to material science or going to another major.
Hey, I'm Matt Masterson. I'm Chemi, but I'm thinking about switching to Math Sci. It seems a lot more flexible and a lot more tight-knit community than Chemi.
So every professor here that I'm aware of is a research professor, so they all conduct their own personal research. They're all full doctors, so they all have their own labs. I currently work with Dr. Breiber in the Polymer Science Lab, which is right upstairs. We have a few different projects that are going on right now. Should I tell you what the projects that we're working on? So we do mostly polymer thin films. So right now we're working on what we colloquially call the transparent paper project, which is where we take cellulose and we change the microstructure, and we hopefully will change its optical properties and make it transparent.
Hi, my name is Justin Koenig. I'm a sophomore in materials engineering, and I chose materials science because it's a blend of a lot of the different disciplines, and I also have an interest in energy industry.
So now that you're in material science, why should freshmen be in material science?
Freshmen should be in material science because we're not as large as the other departments, and so you can build a nice community. That's why we have the lounge. I started spending time there my sophomore year because I needed help with something, and generally it's just my rule of thumb. I don't know something or how to do something on my homework. I'll go to the lounge, someone will probably know.
What other activities do you take part in at UMD?
I'm on our fencing club team, and I just joined our cyclotron project, so.
Interesting. Thank you for your time.
Hi, I'm Valencia. I'm a materials engineering junior, specializing in materials for energy. Now, the reason why I chose materials science is because it's such a broad field. Everything is made out of materials, and it's sad that a lot of people don't know about the industry or materials science, but you need materials for everything, whether you're building a bridge or making batteries or even fabrics. So yeah, that's what drew me to materials engineering, because it's so broad, you can do so many things with it. And I also like looking at the microstructures of things and how they affect the greater picture. So that's why I chose materials engineering.
Hi, I'm Valencia. I work with Professor Hu in the Energy Research Lab at University of Maryland. I'm going to give you a tour of our lab and show you what we're doing. We research sustainable batteries. So we're working with or researching graphene, which is flexible and conductive, sodium, which is sustainable, and wood batteries. So I'm going to show you our equipment we use, so you can follow me. So right here is a powder hood. We use this to measure powder, obviously. We have a laboratory scale that we use, which is off right now, but if you can see it, I think I can turn it on real quick. Okay, well, yeah, so it's very accurate. We could change the units and use it to measure the powder sources. So the next equipment is right here. This is some of the many ovens or furnaces that we use to like reduce materials or just to cause a chemical reaction. For example, for graphene oxide, which is what we use to make graphene batteries, you have to put it in the oven and bake it for it to become graphene. So this is what we use to do that, or some of the equipment we use, and we have other applications as well. This is really important for the sodium batteries. If you know about pure sodium, it's very dangerous if it touches water. So we use this, it's called a glove box, that keeps like water in the atmosphere from, getting in contact with things. So it's very sealed and very protected, and uses like an inert gas to keep everything else separated out. And so yeah, that's what we use to put together the sodium batteries. Very busy lab. So this is my favorite machine. This is the centrifuge. It pretty much uses these little tube things that we use to spin around, or it spins it around, and it separates dense liquid from the lighter liquid. So example is this here. You can see the denser liquids at the bottom, the lighter liquids at top. So we use that to separate our graphene oxide or things like that, and pour off what we don't need and use what we do need to make batteries. So over here, this is more equipment for like making film. There, you might see this in your organic chemistry lab. So here is our vacuum filtrator. You might see this in your organic chemistry lab if you take organic chemistry. We pretty much pour a solution in here, and there's a membrane that we pour it on top of that separates the solutes out of the solution. So pretty much we use this to make a film that we, make the batteries with, or make part of the batteries with, and it's pretty cool and fun. So over here we use hot plates to heat solutions and mix things, and I think it's pretty fun to use too. But what's important is that things, have time to react. So we have a special spot to sit things on a hot plate and let it sit for hours so that it's time to make the change. You can see here's something mixing right now. So that, I guess, part of research is being very patient, that you need to give stuff time to react. And, it's just part of what you do. So, yeah, so that's pretty much the lab. And if you're interested in renewable energy, then material science is, very much needed for that in the future. So you might want to consider material science. Thank you.